All right, so for this first problem, we're completing the pattern. And so as you take a look at the numbers here, you know, that one I could add 8, but obviously I'm not going to be able to just add 8 every time, right? So instead I have to look at like multiplication kind of a thing. And so 4 times what would be 12? That would be 3. Can I just multiply each one by 3? Times 3, yes. Times 3, yes. That appears to be working. We check it, yes, it's all working. And so we take 972 and we multiply that by 3. And that ends up getting our pattern here. So you should be getting an answer of 2,916. And so this is just kind of get our brains into math mode here. Today, our main focus is problems that look like these. So here we have this problem. Now before I read it through, I'd like you to write it down, please. And so what you see here is this is function notation. Now you would have seen this come up like in Algebra 1 at least, maybe even a little bit in geometry here and there. But it ends up being a big part of Algebra 2. So we're going to be working a lot with function notation. In fact, you've seen this pop up a little bit here and there on some of the graphs where you're told like f of x equals an equation like this and you've been asked to graph it. In those cases, I've just said f of x works the same way as y. Well, today we can add a little bit of detail to that. All of this is how we deal with that function notation. So this now needs to go into your notes. So taking a look at what you've now written down into your notes, that first one, we see where it says f parentheses x is read as f of x. So notice this does not mean f times x. Before we got into function notation and would have ever learned this, you would have thought that that meant f times x. But if we meant that, we could actually just write fx. We wouldn't need the parentheses in that kind of a case. So the parentheses are what tells us this is function notation in this sort of a situation. All right? And technically what it means is that this is the value of f at some value of x. And we're going to be using that in that problem that I showed you just a minute ago. You could also say it as the value of y at this value of x. Because notice f of x is used in place of y. It means the same thing. And so in graphing, oftentimes we'll graph f of x equals something because it's the same way that we graph y equals the same thing. Works the same way. Now, why do we have function notation? Basically, it's because of this sort of a line right here. F of 1 equals 5. That's the same thing as saying when x equals 1, y equals 5. Now notice, it's a lot more work to write out when x equals 1, y equals 5. We end up having to write 2 separate statements for something that really is one piece of information. And so this function notation allows us to keep everything all in one piece, all together. And just for technicality, just so you know, yes, we can use lots of different names for these function notations. F of x is certainly what you'll see most. But yeah, you can see all sorts of other things, such as you see there like g of x or h of t. H of t is actually a common one used in physics. It actually represents the height of an object at a given time. So you'll see all sorts of different ones used for these. So if we now go back to this first problem that we wrote down, we saw here, and now we know how to read it right, let f of x equals 5x. So we know the original equation is like a y equals 5x. It means the same thing. And it's asking us to find f of 3. Notice the 3 is in the parentheses. Notice what's normally in the parentheses. X. So yes, all this really means is plug 3 in for x. And so if I go over to my equation here, I'm going to write it as f of 3 equals. Notice it's no longer f of x equals, it's f of 3 equals because I plugged something in for x. So it's going to equal 5 times 3. And so whatever's in the parentheses, that is x. And what it's telling us then is that f of 3 equals 5 times 3. So in other words, f of 3 equals 15. That's all we have to do to get our answer on this one, but knowing how to use the notation is, of course, what it's really about here. All right, I want to continue practicing this idea. So find f of 10 for this equation, please. All right, so in order to do this then, we're looking to figure out what f of 10 equals. And so yes, I actually want you to write out f of 10 equals instead of f of x equals. When you write f of x, this is still an x. When we write f of 10, it is now going to be a 10. That's telling us that we're substituting that in for x everywhere where we see an x. And so then in this case, f of 10 equals 3. And that's it. That's all we got to do. Now this is just dealing with equations. But functions can be represented in lots of different ways. They can be represented as tables, and we can apply the same sort of a process to a table like this. I'm going to reuse this same table for multiple problems, so go ahead and write down the table now, knowing that it's going to get reused for more later. All right, so in solving this one, we're trying to find out what f of 1 equals. Now, there's no calculations to do in this case, because we don't know what the equation would be that represents the situation. All we have is a table of data, but we can use that. I'm looking to figure out what f of 1 is. Now again, remember that whatever's in parentheses, that is our x value. So basically what this problem is saying is it's the exact same thing as saying if x equals 1, what does f of x equal? And so I'm going to go over to my table, and for my x, I'm going to look over to see where x is 1. You can see it happens right here. So if x is 1, what does f of x equal? -4. And so then that's the answer. F of 1 equals -4. And so one other thing that you can see out of this is that when we write f of 1 equals -4, it's giving us the same information that a coordinate pair would too. Because it's telling us that at an x value of 1, we get a y value, or in this case an f value, of -4. That tells us the exact same information. Both of those mean the same thing. All right, so for this one, we're figuring out what f of 4 equals. Now remember, whatever is inside of the parentheses, that is x. And so I go up to my table, I find where x is, and I'm going over to see where it equals 4. Happens right here. So if x is 4, f of x equals 7. Hence, f of 4 equals 7. All right, now for this one, it's asking a very different question. Notice here where it says f of x equals 5. And so we no longer are given a number that's inside the parentheses. So this 5 is not x. It's f of x that equals 5. So that tells me, like, if I'm looking at a table like this, that tells me that I'm looking at the f of x's, and I'm looking down here for when it's 5. So look at your table in the f of x row. Where does it equal 5? You should be seeing right here. This is the part that we're looking for. This is where f of x equals 5. And so when does it happen? It happens at 6. And what equals 6? X does. And so the answer here is that x equals 6. And so when x equals 6, f of x equals 5. Or if you want to get extra fancy, you could give your answer in that same function notation. You would say f of 6 equals 5. You could, but typically you'll just have to say that. On these three problems, I'd like you to do whatever you can do. I'd expect you to be able to do 2 of these really straightforward and easy. One of them may be easy, maybe not. It kind of depends. I want to see how you can do with it first. We'll talk through all 3 of them here in a moment. For the first one, in this case, we're finding f of 2. So I'm going to go f of 2. Notice I put the 2 in the parentheses. X is normally in the parentheses. So it tells me to plug 2 in for x. So it's going to be 10 times 2 minus 3. And so as we show our work, we keep that f of 2 written there. So 10 times 2 is 20, minus the 3. Every line I write the f of 2 equals. That way I'm keeping track all the way down of what I put in. So your final answer for that first one is 17. The second one, this is the one that if something was going to trip you up, this is the one that I was betting would do it. Because in this case, we are not plugging 7 in for x. Notice here what it actually says. It says f of x equals 7. And so if f of x equals 7, that means I need to take where f of x is, and I need to replace that with the 7. And so this equation is actually going to be 7 equals x plus 4. And so notice here in the original problem it said find x. Notice what that leaves us finding. It gives us an equation with x in it, so I can now solve it for what x would be. And so we do the algebra. Remember, we talked recently about how do we need to show the algebra. I want to see that, minus 4 on both sides. And so you end up with an answer of 3 equals x. And yes, that's how all your work should look. All right, and then for this last one, we're finding f of 0. Again, the 0 is in the parentheses, so I plug it in for x. So we're going to go f of 0 equals 4 times 0 plus 7. So f of 0 equals, well, 4 times 0 is 0, so just equals 7. And so f of 0 equals 7, and we're done.